Great. Thank you, Justin. So I'll start by saying that at Northwestern, we completely understand that AI is a cross-disciplinary effort and it requires a robust community. AI at NU is a community that we foster as we aspire to become a hub for AI expertise. And at the Institute for Augmented Intelligence in Medicine, we expand this community in the healthcare space and work with AI at NU to create vibrant collaboration across technology and clinical applications. And there's a QR code if you want to learn more about us. The reason I set that up is I have this intro slide, which is a list all of my collaborators, because generally in academia, we like to cite everything. Most of my career has been outside of the academic space, and I've worked in healthcare insurance and management consulting for over 20 years. And my role at the Institute for Augmented Intelligence in Medicine is really to create that collaboration between our academic research and education focus with industry leaders who are interested in helping us understand how to scale new innovative solutions. So let's get us started. So everywhere we go, everything we do, we are producing data. And that data is being used in an algorithm to predict what we will purchase, where we might go, and what we might do. So I'm just going to read off a few of these stats. Snapchat, 2 million snaps. Twitter, 500,000 tweets. TikTok, 167 million video views. And Google, 5.7 million searches. That's per minute of every day. So as you can see, a lot of money has been invested by companies, both large and small. And this has led to some success and some failures. So we'll talk a little bit about that. I don't know if any of you remember, but in 2011, when Jeopardy was won by Watson, we thought this was the dawn of the machine era. So everywhere on the news, they were talking about how machines would replace humans. And then more recently, right, we saw that there was news regarding ChatGPT. And again, there was a lot of chatter about how the machines would replace the humans. So we definitely need to consider how AI falls into our overall, work and as well as home. So this first one is, oh my gosh, 20% of all jobs are going to be gone within 5 years. And then this next one is talking about, raises the question of the next robot doctor. It shows that ChatGPT can pass the US medical licensing exam without any special training. But I want to say not so fast, right? The problem with truly unfettered artificial intelligence is that the machine learns from the worst of us and not the best of us. And so here's some high profile examples. In 2016, Microsoft released a AI chatbot.
Hello, can you hear me?
Yes. An AI chatbot that was immediately started spewing out racist and xenophobic tweet chats. And this was done within a matter of 16 hours, and Microsoft shut it down. They tried again with a robot called Zoe, and they had similar results. So then, let's see. Oops, I'm trying to get this. Sorry. It's supposed to be a build slide. So the next thing is that Google released a sentiment analyzer, and in the form of a NLP API. It provided negative and positive sentiment rankings based on sentences and words. And interestingly enough, it turns out that the ranking, if you say things like I'm Black or I'm a Jew, is negative, and that if you say I'm white or white supremacy, it got neutral ratings. So Google had to apologize for their sentiment analyzer being biased. So you thought, okay, like maybe we've learned something, right? But once again, we had another try in 2021, and this time in South Korea. And again, guess what? They had to pull the chat box because it started talking in homophobic slurs. And why is this? It's because the actual human language is full of bias, and the machines just amplify that effect. So we need humans in the loop to ensure that we're reflecting not just the worst of us, but also what's the best of us. And so if you think about like human trajectory, right? We keep getting better, we're getting more integrated, and like things that were acceptable in the past are not acceptable anymore. Things that we didn't understand, we understand better. And the problem with machines is they learn from our past, but they can't learn from our future because it hasn't happened yet. Only humans have the ability to do that type of, visioning. So, it's funny because I brought up all these examples, and it's not necessarily in healthcare. And so I'm sure most of you will remember this quote. But as it applies to healthcare, we've seen some pretty big failures despite all the hype and the money that's been invested. So last year in January, IBM Watson was sold off after many failed attempts to try to implement it into a healthcare setting. And all told, I've been told by industry sources that $4 billion was invested into Watson, and they sold it for the bargain basement price of $1 billion. There was another exit as well. Google in 2006 tried to create an electronic health record. There was a lot of concern about the privacy, whether or not Google was capable of keeping it private. And then in 2012, they discontinued the EHR. And then in 2021, Google exited, disbanded its health division altogether. They're still doing some health work, but they don't have a division that's completely dedicated to health anymore. Another venture that garnered a lot of attention, especially since I was on the insurance side of the house at this point, is this Haven, the Amazon, Berkshire Hathaway, JP Morgan venture. It was a lot of money and a lot of people banded together in order to disrupt healthcare. It ended up after disbanding after 3 years. And so then, my title, I'm sure what these efforts have in common is a lot of money and companies with a huge amount of expertise in technology and the lack of ability to translate that into the healthcare world in a meaningful way. We already knew this, but to quote someone we all know, nobody knew healthcare could be so complicated. And the question is, why is that? Healthcare is very local and individuals are incredibly variable. So efforts to create a factory model of healthcare have to recognize what can be standardized and what cannot. And so healthcare is inherently very personal and human. So I'll start by, I think probably most of this audience is aware, you already know that the data science pyramid. So take a look at the steps you need to take before you climb the pyramid of data science. So all the work that we do to collect and move and store and explore and clean and transform the data, that's 80 to 90% of the work before you even get to the fun stuff of creating algorithms and models. So now, if this makes everything seem very organized, I'm going to show you what that looks like in terms of in the healthcare space. So this is a sampling of all the work that's involved at each level of that pyramid. So you can see that there are multiple EHRs, multiple standards, as well as systems for linking data, validating the consent and finding the right curated data sets, understanding the underlying bias and looking at data quality, and then all of these, and then you get to the top and you have to figure out what tools you're going to use. And all that happens before you even get to the fun part of like the learn and optimize. So it turns out that healthcare data collection, which goes into research, is pretty problematic. Now, this is a study from 2001, but it's pretty much, we haven't changed a whole lot about healthcare. And so, if you take 1,000 people, if 800 of those people have symptoms, only about 327 of them are going to end up seeking care. And out of those, like only 8 end up being hospitalized, and less than 1 of those gets hospitalized in an academic medical center. So then where do you think we generally hold clinical trials and collect data and run machine learning algorithms and train them on what data? You guessed it, academic medical centers. So what I find is really interesting is if you take a look at this study that was published in JAMA in 2020, it shows that, from a geographical distribution standpoint for patient cohorts, these are the clinical machine learning algorithms and the cohorts, patient cohorts that are used to train them. And you can see that the East and West Coast are very well represented. And Justin, you know this, right, from the work that you do, there seems to be a lot of focus on the East and the West Coast when it comes to AI technology, and not a lot of focus in the Midwest.
Right.
Yeah. So, when we in healthcare look at this, what's really glaring is that all the states that are missing are all those states in the middle where healthcare is really like there's a lack of access as well as just poor health. And so you can see how problematic that is, that we're collecting data at academic medical centers. We're running these algorithms on the East and the West Coast. And, it isn't surprising that some of these algorithms may not turn out to actually do a very good job of predicting either risk or health. So that's one issue that we face in healthcare. The other issue, I don't know if those of you who are not in healthcare know this, but doctors hate EHRs. Actually, nurses hate EHRs. Everybody I know in a clinical setting hates EHRs. And so my favorite quote on this little thing here is, fill in the blank, click lists are soul crushing. EHRs were mostly created to capture data for billing purposes, right? And so the technicians who created EHRs, they're going to have a hard time getting quality data entry for a lot of reasons, and not least of which is that their users just hate the system that they're working in. So that's another issue. And then we come to the other reason why data quality is a problem in healthcare. I'm a data management professional, and so believe me when I tell you I love standardized code sets. The ability to ensure that people are all saying the same thing, that's awesome, right? So a little backstory, in 2013, we transitioned from version 9 to version 10 of the International Classification of Diseases, ICD. It was a really painful effort that I was actually a part of, that took 7 years and moved us from 13,000 codes to 68,000 codes. That's 5 times as many codes. So we in data management know that the more granularity you have lends more flexibility to answering questions, right? What have you got to lose? However, perhaps some of these codes were a little bit too specific. So I'm going to take you through some examples. So in our quest to make really specific data code sets, right, we might have gone a little bit overboard. So imagine you're sitting in front of a computer screen and you're trying to code an encounter with a patient. How often do you think any of these things actually apply? Struck by a turtle, walked into a lamppost, injury due to activity laundry. And then on the other hand, these sets of codes are pretty interesting too. A very low level of personal hygiene could lead you to a bizarre personal appearance, which can lead you to a fairly useful code, social inclusion, exclusion, and rejection. And so just for fun, because I love codes, I'm going to also show you some other ones. So burn due to water skis on fire, drowning and submersion due to jumping from a burning fishing boat. My son loves reenactments of history, so I can sort of see a legal intervention involving a bayonet, but it's probably still pretty rare. And then lastly, problems with your relationships with in-laws, which I think could apply to pretty much everyone who is married. So I've given you a lot of problems and issues around AI in healthcare, but there's an interesting dynamic that I want to talk about as well, and that I'm hoping is part of the solution for how we solve some of these problems. So I think academic research I've only been in academia, as I said before, for the last 2 or 3 years. Most of my time has been industry. So I have like a unique ability to view both sides. And in academic research, we can be incredibly innovative. And because we're allowed to ask, lots of questions, there's very loose governance of tool sets. So we create handcrafted tools, basically a craftsmanship model, because, while we don't have a lot of money in academia, there is one resource we have a lot of, which is smart students. And so you take a bunch of smart students and you let them loose on Python or R, and you get a bunch of code that is very bespoke and very hard to recreate and not scalable. On the other side, my last gig, I was VP of Enterprise Data Solutions at Blue Cross Blue Shield Association. And the national data warehouse that I was the business owner for, it had been running for, at that time, 10 years. And it had, Blue Cross, insures 1 in 3 Americans. So you can imagine the massive amounts of data and the huge amount of scalability, highly governed infrastructure, lots of processes to ensure that, everything keeps running the way it should. But it actually is an inhibitor for innovation, because everything we did, it took us 18 months to put in any changes. But on the other hand, we have massive financial resources in order to do so. So what we actually need is to create communities where practitioners of AI from academia and industry start to learn from each other and figure out, how do we harvest the good on one side and take the innovations and say, oh, okay, like this is how you would scale it. So that's the challenge I would put, especially to this group. So Justin, I'm not really monitoring the chat, and I noticed that there's a bunch. So if you want to interrupt and ask questions, feel free.
Sure. Yeah, I certainly will. I think people were doing a lot of laughing about the various codes because they were just kind of ridiculous.
Yes, it's fun though to go through them.
Somebody said there's a code for karoshi, which is a Japanese term for death by overwork. So
well, we're all probably getting there, and hopefully AI can help with that too, right? So then I guess the next question is, how do we address these gaps? So, I'm in academia, so I have to show you the actual article this came from, right? But I think what's more interesting is to look at humans are good at emotion, intuition, common sense, creativity, specificity. And then, what machines are good at is probabilities and analyzing huge amounts of data, performing repetitive tasks, being objective, sensing patterns. Interestingly, machines are bad at all the things that we're good at. And we're bad at all the things they're good at. So I think, that's why I hate to talk about AI as artificial intelligence, because I think we need to talk about augmented intelligence. And that's the approach that we need to use. So in healthcare, it's a really complex socio-technical system. So we have to think kind of beyond that individual technology and think about the system as a whole. I did say to you, healthcare is complicated, right? So within that system, there's a lot of interplay between social and technical components. The way the technology is used depends on this broader context of like the people, other technologies, the workflows, the goals, the cultures. It's not a surprise that like within the medical field, the collaboration is key to identifying challenges and figuring out how do you, like triage somebody who might be going through a crisis. So end users also play a critical role in the development of successful AI within the healthcare. And this is where, I want to talk about some of the work that we've done in order to show that, we can make AI work within healthcare. It hasn't typically worked. And so it's important to look at some models that have worked. So in the past several years, we've worked with several clinical teams to understand their expectations for AI and how they're using AI in the real world and how they want AI to help them in the future. So most recently, we've been working with a cardiology team that's piloted a machine learning powered tool that's embedded within their electronic health record. And it generates regular reports of patients across Northwestern medicine who are at risk for advanced heart failure. This is one of a small number of successful stories of integration and adoption of machine learning in the clinic. So using this case study and a few other recent projects, we recently published the work that the role of nurses, clinicians, and staff make in how to make these tools successful within healthcare. I do want to acknowledge here that this work was led by phenomenal PhD students, Blaine Rothrock and Maura Lola. So there's some citations at the bottom if you're interested in learning more about them. So in successful cases, clinical teams are really heavily involved in the data curation, labeling, and validation. I don't know if you remember that pyramid that I showed you, right? The 80 to 90% of the work. Here's the thing, like the AI technicians and experts are not the people who can do that. It's the clinical experts that can do that. So in the cardiology example, it's the nurses that perform initial chart review of patient charts in order to train the models. You know, they look through Epic, they look through other external systems, and they made sure that they really understood that patient, and then they helped to label the actual data. And that's how you evaluate whether the data was actually, the model was performing or not. In the real world, these algorithms are never perfect. And so we need to figure out ways to identify when it's wrong and when it's an exception case. So there's an example of a nurse who said, hey, you know, like when I look through this, you know, this list, the computer says this one patient is at stage D, when I know that the patient, even though I understand why the model flagged that, and because the patient was hospitalized 5 times, but what the model doesn't know is that the patient was hospitalized because of COVID, and now they've recovered. And so the things that made the hospital flag this patient as being critical and at stage D risk for heart failure is just not valid. And so like those are the things that nurses and doctors have to figure out. So, and then, you know, like the last step is, what do you do? Like, because you have these predictions and, you know, the hard thing is, what do you do next with them? So in the case of heart failure, if there's a prediction that the nurse agrees with, then what do you do, right? In each individual case, there's some people who are very confident with what their next steps are and other people who are not. So it's really important to clearly document the workflow of what comes next. And so kind of to sort of wrap it up a little bit, and then I'll turn it over to some questions because I wanted this to be more of a conversation. But one goal of this work is really to raise awareness that there's an important role that people have, in particular clinical teams have in successful AI deployments. So we want to motivate more documentation and sharing of the efforts and the workflow strategies that are used in the design and implementation of medical AI, so that, you know, we, as people are trying to implement it within their own spaces, they have examples that they can follow. Whether those examples are failures or successes, they're all important for us to understand, how does this actually work within the specific ecosystem that you're implementing it in? And that's not that different from every other technology implementation I've ever been in. You know, you can take something as simple as like Calendly, right? And even though that's very modularized and seems like very easy, you as the human have to go in there and you have to configure it to your specific needs. So there's no magic easy button in healthcare. So.
Well, thank you, Nan. It was good. Yeah, as you were saying, if people wanted to either unmute or type questions in here, more than happy to take those. Nan can read those, I guess, along the way. So could I. One thing, I guess my first question here was, you and I talked about it a little bit before everyone got on, but this whole idea that, there's research groups that are doing stuff in this, and then you have industry that's doing stuff in this. And I'm assuming, I mean, that happens everywhere. Why do you think that's particularly, I guess, a problem right now in healthcare?
Well, I think what happens in healthcare is that we have different incentives. On the industry side, we're really just so busy trying to figure out how to make what is currently in place work and work more efficiently. So a lot of it is about efficiency. And then on the academic side, it's like, this true idea of what is possible. And let's just try to figure out and answer some cool questions. And sometimes those questions, frankly, are, a little bit esoteric, or, somebody approved them, so somebody must have thought they were useful. But what is done in research does not always translate into something that, on the industry side, that they feel like they can implement. But frankly, also, I don't think the two talk to each other too much. I mean, I never really talked to anybody on the academic side when I was on the industry side. And that's kind of like the mission and the pull of what I'm trying to do, is talk to as many of my contacts on the industry side as possible about what's going on in healthcare on the research side, and get them involved in projects as we go.
Gotcha. And tell us a little bit, I guess, about how you're a part of Northwestern, but you're also not, right? I mean,
yes. So that's an interesting. I am part of Northwestern. The Feinberg School of Medicine sits within Northwestern University, but also within Northwestern Medicine, which is a health system. And the faculty at Northwestern Feinberg are also clinicians that practice at Northwestern Medicine. So it's this kind of odd Venn diagram of the three.
it sounds like, though, like you're saying, that's exactly kind of what we need, I guess, is
Yes.
this institute that collects people. You mentioned about going to a conference, I guess, at all that's out in DC coming up. Is that in this same sort of realm?
Yeah, so it's trying to be. It's one of the many programs that is trying to bridge the gap between like the technical side. So as I mentioned, AI at NU is actually situated, it started within the engineering school. And it was kind of an effort to be more broadly inclusive beyond engineering, beyond the technical. And we started sort of somewhat separately. And, we've been collaborating together where there's, things in healthcare, they come to us, and then things that are like really specific to like the technical realm, like we go to them. So there's a whole materials engineering piece of this too, of like, what are some cool innovations that are happening in materials engineering? But then there's the data that gets generated out of that like has applications on the clinical side.
Great. So we got a couple of people raising hands, which is great. I love that idea. Deepika, did you want to unmute and?
Yeah. So I guess I had a question about, how FDA has these new regulation of software as a device. How do you see that playing into AI adoption? Or do you know of any people who've been able to get approval as a device?
There has been some approvals. I don't have specifics, but what I would tell you is there definitely needs to be some governance, but the cycle for FDA is a really long one. And the cycle for technology is very rapid. So one of the things that we're going to have to figure out is how do we balance between the needs for safety, especially in medical devices, and the need for us to continually evolve on the technology side.
Great.
Thank
you. The other thing I'll say about that is I've noticed too that there are people who are doing consumer health apps, and they label it as sort of like fitness. And so by doing that, they're trying to circumvent the whole FDA, software as device type of regulatory hurdles.
Yeah, because I think their previous guidance was as long as you used in a healthcare setting with a healthcare provider, you kind of got away with not labeling it as a device and not needing any review. But with the newer guidelines, I think they're moving away from that. And I think it's just a tough battle if you develop something that you want to be used clinically.
Yeah, I mean, I have one of the examples of a machine learning model that was trained at Northwestern. It identified COVID positive patients, via like an X-ray, and with something like 80% accuracy, or like to the level that a trained eye. And so if you have a situation like a pandemic where you're short staffed, it would be great if the AI can suggest to you, hey, these 5 or 6 patients that just came through potentially have COVID. But in order, like that was never actually sought for FDA approval, because one, by the time the pandemic, by the time that we developed this machine learning model, it was no longer really like by the time you get it approved, it wouldn't have been applicable anymore.
Interesting. Yeah. So it's just sort of that lag and finally getting things approved, and times have changed. Eli, you want to ask your question?
Yeah, thanks for taking my question. I guess I have a question about maybe a potential problem coming our way. And I think about once people had access to Google and they were able to Google all these health symptoms and get all this advice that was kind of outside of the medical establishment, and leading to all sorts of frustrations and people thinking they maybe know better than doctors. Now I see things like ChatGPT and the democratization of a lot of these AI agents, maybe taking that to a whole new level where, you already see people having trust issues with their healthcare providers. But then, like you pointed out, some of these AI agents can be wrong, but people might trust them as seeing them maybe as less biased. I'm curious how the healthcare industry can adapt and mitigate that, if it goes anyway, like the way having access to Google went with healthcare. So just curious if you have any thoughts on what we might do to preempt that problem a little bit.
Yeah, I don't know that I have a solution for that. I think that those are conversations that we're having right now, is trying to figure out. I do think that, things like ChatGPT fundamentally change the field for us in terms of, not just medicine, but also in learning. You see universities saying, hey, you can't use this. And then you see other people actually saying, you will use this, but you will cite it. So, I mean, I don't know, I think the whole trust issue is a societal problem that it's not just for medicine, it's for all of this in general. When do we learn to trust each other? Yeah, I wish I could answer that, but I don't have a good answer.
Yeah, and it presumptuous of me to think there is a simple answer. I think we'll unfortunately learn that one probably the hard way as we get into it. But well, thanks for the thoughts on it, though.
Yeah.
Cool. Thanks. Rich, do you want to go next?
Yeah, sure. Thanks again. Great presentation. I'm kind of curious on if you have methodology for either your product development or feature development. I know there's a lot of analogies that have been drawn between scientific thinking and product thinking, like design thinking. I didn't know if you went through a specific methodology when you're developing or tuning models and things like that.
I will go back from an academic standpoint and say most of the research that gets done is bespoke. So dependent on who the scientist or the researcher is will depend on what frame they use. So some of the examples that I gave on the clinical application for, in cardiology, Maya, all her background and training is in human-centered design. So she approaches it from a very much, what is the workflow? What is the person? And so, it's probably a little bit different than how others approach it. And so, unfortunately, like I said, within academia, it's very bespoke and it's very dependent on who the researcher is and what, where they trained and what they're interested in doing.
Okay, thanks.
We have a question here on the chat. I'm not sure if you would be able to,
Yeah.
it's by Nick, healthcare having an abundance of high-risk applications. Are there any standards or regulations emerging at the organizational level for ethical use of data or fairness of application results?
Well, I will tell you that there's a lot of interest and there are definitely guidelines. There's a coalition and I forget the name of it, so I'll have to find it later, Justin, and send it to you. But there's a industry coalition about healthcare AI and sort of like what are sort of the guide rails for that, as well as the WHO has a series of guidelines. I actually had a slide on that and I took it out for the interest of time. But, like everybody is trying to think about this ahead of, sort of the genie being out of the box.
Sure.
I saw Kat ask the question, where can I learn more about AI in healthcare? I'm a nursing student and I know it will affect me sooner rather than later. Interesting. I'm not sure about exactly with the nursing side, but this presentation I'm giving to the Triple AI conference in DC next week. And they have a bridge program. It's called Technology in Nursing. And so, this is like the third in a series. And then after that, there's going to be some conversations about how do we work, with nurses in order to make sure that AI actually gets implemented and considered, like within the workflow, the nursing workflow, because it's much more likely that the nurses are the ones that are touching the EHR and like looking at these AI algorithms as opposed to the doctors themselves. So we do have one of the things we're trying to we put up and it's called the Health Data Gym, and it's healthdatagym.org, and it is trying to put together some data sets as well as some tools and like that we've had experience working with. So if you're kind of interested in the data side of it, that's a place to go as well.
That's great. Yeah, I will make sure that gets posted, healthdatagym.org. I had another quick question too. I mean, I just think it's fascinating with regards to the bias and the data, that so much data is coming from the coast and also coming from these facilities where frankly it's probably a lot of rich white people that are there. How are we combating that? Are people starting? I mean, you have the data gym and stuff like that, but in industry, are we really moving the needle at all on that, or is it just kind of like, well, we're stuck with what we got?
No, we are definitely, the researchers themselves recognize that this is a problem. And so there's a lot of efforts we're doing. It's funny that you asked that question, because I actually had a slide that talks about all these different, research collection efforts where we're trying to reach out. Like there's an Alzheimer's research data, set that is done in Wisconsin, where they're purposely going out and collecting data for people at risk for Alzheimer's, because it's, potentially hereditary, as well as people who are, and making those studies. And they're doing the outreach and bringing people into the medical center as opposed to like waiting for people to come. There's also like a federally funded research called the All of Us, which is attempting to create like recruit like 1 million patients with genetic data. And that, that's making an effort to collect diverse genetic data. and making that available for research. So there's definitely pockets. And if you go to Health Data, Jim, like we kind of try to make some of those more available to people.
Interesting. Yeah, I wonder if there's something with like ancestry.com or some of those other things that where you could, you know, I'm guessing people have exclusively signed away that they wouldn't give that away, but maybe there's a checkbox, you know, when they go in and do some of that stuff that they would donate it.
Yeah. Yeah, that kind of like circles back to, you know, the conversation you and I had like in the podcast about like consent and your data being your own. So historically, we in healthcare have been very, very bad at sharing data. And you think about the incentives, right? You know, the health system, the hospital doesn't want to share data with the health insurance company because they think, well, if the health insurance company has the data, they're gonna, you know, squeeze me for every penny. And vice versa, like, you know, the health insurance company doesn't want to share data with the doctors because they don't want this hospital to know that, you know, this procedure is getting paid more at another hospital. So like these are perverse incentives that for a long time have stopped us from even sharing our data or even wanting to share our data. What has changed is sort of in the waning days of the Obama administration, one of the few truly bipartisan legislation is called the 21st Century Cures Act. And that basically was trying to free up data for research. And in it, it said that my data, me, the patient, my data is mine. And people have to give it to me with, I forget the actual wording, with minimal effort. And so as a part of rulemaking, the Office of the National Coordinator for Health Information Technology has put out a bunch of rules that say that both health insurance companies and as well as health systems have to make your data available to you via API, and it's a FHIR version 4 standard. So as of January of this year, theoretically, you should have access to your data. So that means that, you know, in the future, you can go in and you can say like, hey, I want my data to be used for research, and then they have to share it. Whereas in the past, they didn't have to before.
Oh, that's exciting. Very cool. Very cool. Any other questions? Well, Eli, you send another one? Getting unbiased data is a huge challenge.
Yeah, I think exploring what's in the data and sort of, you know, a lot of this is on the person that's actually doing the data analysis to kind of recognize, you know, what is, you know, like it's that common sense test, you know, is it reasonable that like, you know, 100% of the people are diagnosed with this disease?
Yeah,
probably
right.
not, right? So
Right.
like there's a little bit of, and that's where, you know, I think the technology has to be married with the clinical expertise, because, you know, like clinicians can look at something and nurses can look at it and go, yeah, that doesn't seem right. And so until the data gets better, like the AI is not gonna, you know, AI is not magic. It can't make up for gaps in the data.
Yeah, and people could just gotta not be lazy, you know,
Yeah.
in some ways.
Yes. Yeah. Yeah. I'm encouraged though, because when, you know, I stepped away from industry about 3 years ago, and I'm sort of like advising more startup type of companies, which is a totally different animal, right? But when I was in like the larger industry area, it seemed like there were definitely people who were talking about ethics in AI, because they wanted to, you know, like they don't want bad publicity from, you know, I don't know if you guys know, but United Healthcare, for instance, had this machine learning algorithm that they use in order to triage who would get, you know, care management resources. And it was based upon cost. And because historically Black, you know, African Americans tended to access the healthcare system less, they tended to cost less. So, which meant that the algorithm would allocate resources to somebody who was, you know, who wasn't as severely ill because of race. And that was because they took race out of the equation and just considered costs. And so these are just some things that I think as a healthcare industry, we're trying to avoid. So there are lots of conversation to talk about ethics and AI and bias and like being aware of that.
For sure. That's great. And any other questions here in the last few minutes we have? Looks like someone raising their hand. Madhu.
Yeah, hi, thanks for taking the question. In one of the slides, you mentioned about people, processes, technology, infrastructure, and culture. I may be missing one more. Can you spend a little bit of time on each of those and why each of those matter for AI and how they matter?
Okay, so you're gonna put me to the test, right?
No, I want to understand really.
No, I'll be perfectly transparent. Like I said before, the like the slides are a collaboration, and let me go back to it and share it between a bunch of different people's work. So if you here, let me share that slide again. So basically, the way that technology is used within socio-technical systems, technology, it depends on the broader ecosystem of people, other technologies, workflow, goals, and culture. So things like social norms and expectations are going to impact people's willingness to use the technology and influence how that technology is actually used. So any new computational tool for health, or including machine learning, predictions, intelligent decision support tools, are going to need to interface with these socio-technical systems. So essentially what this is saying is work is a complex system that comprises of both social elements, people, workplace culture, and norms that emerge from interactions, goals, and technical elements. And technology, the affordances of the tool, the parameters the tool abides by, the infrastructure and the processes should be augmented. And like, you use all of these to figure out what needs to be replaced by automation versus what shouldn't be replaced by automation. If you look at this is actually lifted right from a study called Applying Organizational Psychology as a Design Science. And they talk about it in much more detail than I'm capable of, since I didn't do the actual research.
Okay, thank you.
Excellent.
Great. And,
Right.
I'm also happy to, like, I think Justin, I'm available on LinkedIn, is my most common mode of communication with folks. And so if you have any other questions, please reach out to me, or if you want to collaborate. As I say, like, the AI space is all about creating this big community. One of the, I think, what's been problematic in the past is that people have tended to create these little silos. And what we know about technology today, and especially AI, is that we build upon each other. I mean, that's what's beautiful about all the work that you guys are doing. And Justin, I know you're doing this as well, is there's so much open source software out there that is, like just building upon, like standing on the shoulders of giants kind of idea.
Absolutely. Absolutely. And yeah, Nan, I put your LinkedIn URL here in the chat, so I'm sure you'll be getting a lot of people reaching out to you. Also, Rich just commented, I like augmented intelligence, and I think that's what I've been telling people as well, with regards to, and whether or not it's healthcare or whatever, it's basically kind of, as you were talking about, kind of bringing the best of both worlds together. Is how can we use this intelligence or this machine learning, this technology, I guess, to kind of make humans better and make machines better as well together.
Yeah,
That's
absolutely. Well, thank you for having me.
Yeah, thank you so much for attending tonight, sharing all your knowledge. This will be out on our YouTube channel here in the next couple of days or so. I will post it on the meetup page for people to take a look at it and share with their network. And please be sure to come back next month where we'll be talking about data platforms, preparation in Azure for AI. But thanks, Nan, again. I appreciate it. Good luck at the conference you'll be speaking at in DC in a couple of weeks, and look forward to keeping in touch in the future.
Great. Thank you.
Thank you.
Thank you.
All right. Take care, everyone.